Artificial intelligence, or AI, is changing the world as we know it. From self-driving cars to personalized medicine, AI's potential seems, well, limitless. One area where AI holds immense promise is research. Just imagine AI sifting through mountains of data, spotting patterns, and making connections that would take humans years to uncover. This is the exciting potential of AI in research, to accelerate discovery and solve complex problems. However, with this great power comes great responsibility. As with any powerful tool, AI can be misused, intentionally or unintentionally. When we rely on AI systems to guide research, we must be aware of the potential pitfalls. These pitfalls, if left unchecked, can undermine the very foundations of scientific inquiry: truth, objectivity, and trust. We often think of algorithms as objective and impartial. However, these algorithms are created by humans and trained on data that humans generate. This means that our own biases, whether conscious or unconscious, can creep into these systems. From the data we choose to collect to the way we label and categorize information, human bias can permeate every stage of AI development. Consider facial recognition software, a technology increasingly used in various fields, including security and law enforcement. Studies have shown that some facial recognition systems are less accurate at identifying individuals with darker skin tones. This bias can have serious consequences, potentially leading to misidentification and wrongful accusations. The problem of algorithmic bias extends far beyond facial recognition. In healthcare, AI systems are being developed to assist with diagnoses, personalized treatments, and even predict patient outcomes. However, if these systems are trained on biased data, they could perpetuate existing health disparities. For instance, an AI system trained on data predominantly from urban hospitals might not be as accurate in diagnosing conditions more prevalent in rural communities. Addressing algorithmic bias requires a multifaceted approach. We need to be more critical of the data we use to train AI systems, ensuring that it is representative and inclusive. Developing techniques to detect and mitigate bias in algorithms is crucial. Finally, we need greater diversity in the teams developing these technologies, bringing a wider range of perspectives and experiences to the table. In the realm of scientific research, data integrity is paramount. The validity of any research finding hinges on the accuracy and reliability of the underlying data. However, the increasing use of AI in research introduces new challenges to data integrity, particularly the potential for data manipulation. AI systems, particularly machine learning models, are data-hungry entities. They rely on vast amounts of data to learn patterns and make predictions. This dependence on data creates a vulnerability. If the data itself is flawed or manipulated, the results produced by the AI system will be unreliable, potentially derailing entire research projects or leading to false conclusions. Data manipulation can take various forms, from deliberately altering data points to fit a desired outcome to selectively excluding data that contradicts a hypothesis. In some cases, researchers might not even be aware of data manipulation, especially when working with large, complex data sets. For example, errors in data collection, storage, or processing can introduce unintentional biases or inaccuracies. The consequences of data manipulation in AI-driven research can be significant. Inaccurate findings can mislead other researchers, waste valuable resources, and even delay scientific breakthroughs. In fields like drug development, where research findings directly impact human health, the stakes are even higher. A flawed clinical trial due to data manipulation could have devastating consequences. The digital age has ushered in an era of unprecedented access to information. However, this access comes with a caveat: the proliferation of misinformation and the rise of sophisticated tools that can fabricate reality with alarming ease. Among these tools, deepfakes stand out as a particularly potent threat to truth and trust. Deepfakes leverage artificial intelligence, specifically a technology known as generative adversarial networks, or GANs, to create highly realistic but entirely fabricated images, videos, and audio recordings. These GANs are trained on massive data sets of real images and videos, learning to mimic the nuances of human appearance, speech, and behavior. In the context of research, deepfakes pose a unique threat. They can be used to create fake evidence, manipulate scientific data, or even impersonate researchers to spread misinformation and sow doubt in legitimate findings. Imagine a deepfake video of a renowned scientist presenting fabricated research findings at a prestigious conference. Such a scenario, while seemingly far-fetched, highlights the potential of deepfakes to undermine trust in scientific institutions and experts. The rise of deepfakes necessitates a multi-pronged approach. Developing sophisticated detection tools to identify and flag deepfakes is crucial. Raising awareness among researchers and the public about the dangers of deepfakes and promoting media literacy to discern real from fake are equally important.